It's 10:42, so let's get started without further delay. So welcome. I'm Vamsi Krishna. I'm solutions engineer from Confluent. So today we are. This is going to be a workshop. So today I'm going to do some kind of theory as well as hands-on. So you get to experience, you get to learn the concepts as well as you get to actually go and implement it or experience it as part of live workshop. And the way I have designed the whole content is we are going to use real cloud-based resources. I would, first of all, even before going and talking about the content, I would take you through how to sign up and create an account. So we will actually go and play with the live account itself, the live cloud account itself. Can you all say hi in your chat box? So I'll come to know how we can interact using the chat box. Awesome. Hello, Vidyadhar. Hi. Super. So, yes, Vidyadhar, I can't hear you, but can you hear me? Awesome. That's good to know. Nice. Super. So let's get started. First of all, like I said, this is going to be a workshop, a hands-on. So I would actually ask you guys to first sign up for Confluent Cloud so we can actually get doing the real stuff. I'm going to paste a link in the chat box using which you can actually go and create an account. While I do that, I'll also walk you through the steps of creating Confluent Cloud account. So you can click on the links. Meanwhile, I'm going to bring up a presentation. Awesome. So while you go and click on the link, so this is a very quick intro about myself. You can connect with me on LinkedIn. I'm going to paste my LinkedIn details as well in the chat. So please feel free to connect with me on LinkedIn for further discussions. So let's move ahead. First things first, you will actually land up in this kind of page once you click on the link. What you do is you can opt for signing up using Google account or GitHub account or your own email ID as well. Simply fill in this information. We don't ask for any credit card details, so you can simply fill in all this information. And every new sign up gets $400 worth of free credit. So that is more than sufficient for us today. As well, with the leftover credits, you can play with the Confluent Cloud and different pieces of it further for the next 60 days. So I would request all of you to go to click on the link, which will go take you to a sign up page. Fill in the details. You can use whichever method like Google, GitHub, or the manual way, and you will get email verification to the email address that you have entered. Just go and click on verify email address, and that should just take you through the authentication and land you up in a page which will look like this. If you have done the process still here, if you have finished with the sign up, just post number 1 in the chat box. So I'll come to know that the first step of yours is complete and you are ready to go to the next step. We'll wait for about 20-25 seconds for you to finish the sign up process, and then we'll move ahead. Awesome, thank you. So you can as well log into your existing Can you guys see me? Hello, am I audible now? Awesome. Thanks, Anshul. So moving ahead, as soon as you finish the process, you'll get a page which will ask for some details, which I showed you earlier. So you can simply skip that particular page, which there is a skip button on the top right corner. So it will actually take you to a create cluster page. I'm as well going to create a cluster along with you guys. So I'll quickly jump onto the Confluent Cloud page and then share screen for you. Awesome. So I'll explain you many other details as part of the theoretical content. But for now, let's start with creating a basic cluster, which will be good for now. Confluent Cloud is available in AWS, Azure, and Google, all the three providers, and we support about 65 regions today. You can get to choose any region of your choice. Just to make sure that a lot of people doesn't clog one area, you're free to choose any region. For the sake of this demo, let me choose say Singapore and leave all the others as default, and then click continue. It's going to ask for a cluster name. That also you can simply leave as it is, and then launch your cluster. So once you're done with creating cluster, it's going to show you an overview page. If you're doing this for the first time, it will actually show you another page asking for some details. Can you all hear me? Awesome, thank you. Raghavendra, would you mind checking on your side if you have connected with audio? Yeah, so you will get a cluster overview page, which will look something like this. If you're getting a page which is going to look something like this, simply skip by using the cross button on the right side, and you will actually land up to the cluster overview page. If you have already reached this page, just type 2 in the chat box. So I'll come to know that you have finished process till now, and we just have one more step to finish. Sure, go ahead. Go ahead and do it, Anshu. So you'll just have to create a cluster which should auto pop up. It will ask for a cluster. Go and click basic there first, and then you'll have to choose any cloud provider and in any region of your choice. It's going to be same irrespective of where you use. Raghavendra, I guess yes, the audio problem is with you. Others can actually hear me. You can choose a region of your choice, and then if this page pops up, if you're doing for first time, this page will pop up. So you can simply click on the cross button. You should land up in the cluster overview page. I will as well post all these instructions for you in the chat box. If someone has joined late and you want to actually go and create a cluster, you can actually use this link to go and create a cluster. So this will help us to do the hands-on piece a little later. Right. If this is complete, please help me by typing 2 in the chat box. So I'll be sure that you have finished process till there. I hope the cluster creation is complete. It should take approximately just 20 seconds or so for you to create a cluster. So let's move ahead. The third piece and the last piece is as part of the prerequisite activity is for you to create a ksqlDB cluster. You will see an option. Yes, thank you. Yes. So you will see an option called ksqlDB in your console on the right, top left side of the menu. So click on ksqlDB and then click create cluster myself. It's going to come to a page where it will ask for access control. Just click on global access for now. This is good for the demo or for development purposes. Click continue. It'll ask for cluster name and cluster size. Leave the defaults as it is. You need not change anything, and just click launch cluster. So just 3 clicks. You can enable browser notifications if you need. Otherwise, you can simply click not now. So you should see a page which will look something like this, where there is a cluster name and the status should say provisioning. If you have reached a stage till here, you can simply type 3 on the chat box. Will all be good, and let's go ahead with the content. Let's first learn what real-time stream processing is, and then come back to do some real hands-on exercise here. Again, quickly iterating the steps, you can click on ksqlDB, which appears on the left side. Click on create cluster myself. It will take you to a page where it asks for access control. Click on global access. Leave the cluster name defaults as it is, which will appear on the next page, and then click create cluster. It will take you to a page which says cluster name and the status is provisioning. Just leave the status as it is, and you can actually concentrate on the content first, and then we'll come back to this Confluent Cloud UI for doing the rest of our hands-on exercise. Awesome, thanks, Anshul. So cool. Let's go ahead with the content first. Let's learn what real-time stream processing is, and then we'll come back to the hands-on piece. So the topic for today is how can you do real-time data transformations, and we are going to use specifically a particular component or feature called ksqlDB, and we're going to discuss a lot about this in the course of next 20 minutes or so. First, let me start with what is stream processing, why do we really need it, and why you need ksqlDB for doing stream processing. We will learn some basic constructs of ksqlDB, some not so technical, but high-level constructs, what all constitute ksqlDB and how we can use it. I have drafted some use cases that we have seen with a lot of customers, and I try to cover as many industries as possible so you can actually relate to your industry and think of use cases in your own companies and kind of which will directly impact your business. After learning all these, we'll go back to the cloud console and do the hands-on piece. Right. See what stream processing is, right? So today, if you think of our end customers, who is actually consumers of what we build as applications, right? All customers actually demand immediacy. Even if we think ourselves as a customer of, say, an Ola, Uber, or some kind of e-commerce or a banking application, right? We need all the information in as much real time as possible. As soon as you enter a rideshare application, you want to actually see the driver status live in real time. While you're taking the ride, you want to see your travel in real time. Similarly, for your packages, whether you want to deliver a package or you're expecting a package, you want to actually track the package in real time. If you're developing some applications, you want to see, say, all the inventory status and stuff all in real time. Or if you're into banking industry, you want to inform your customers of, say, possible frauds, possible transactions that are happening, the notifications to that. So there is a lot of immediacy expected by customers. Unlike 4 or 5 years ago, today almost all applications are trying to do a lot of stuff all in real time. Now that is what is leading to the next stage, where we are going to collect a lot of data, be it transaction data or clickstream data and so on and so forth. An example of financial transaction, right? So of mobile app, we are just not interested only in the transaction data that is coming in. For you, for example, you want to work on fraud detection kind of use case. You just don't need the transaction data alone. You want multiple data from different streams. You want the relevant customer, the current transaction data, what are the payments that he have already done, what is the geolocation data of that particular user, and so on and so forth. So you actually need multiple streams of data, and you want to do some kind of enrichment or transformation to the data. It could be filtering, it could be joining, it could be aggregating some data and stuff like that. Ultimately, what you want to achieve as a result is uh, generate a data which is easily consumable by the application, in this case a fraud detection application, to go and say whether it's a real fraud or not, and accordingly act on top of it by sending a notification or sending that detail to your infosec team, so they will actually go and verify what's happening in the background. So there is a need not just to collect the data, but also to process the data, again, all in real time. You cannot wait for some batch process to trigger at the end of the day or every 6 hours or so, and then wait for a detection to happen after as a batch process. You want almost all of it to happen in as much real time as possible, right? Now let's say, why do you need ksqlDB for doing that kind of real-time processing, right? People who know of Confluent, you might already know a very quick background about Confluent. There were three people who were working back in 2010 in LinkedIn. They had this problem of dealing with huge volumes of data. Now that's where they actually invented Kafka, and then later open sourced it to Apache Foundation. It became Apache Kafka, and they came out of LinkedIn in 2014 and started this company called Confluent. So the founders of Kafka are nothing but the people who are actually running Confluent today, and we have built a lot of ecosystem around Kafka as Confluent ecosystem that is helping do the real-time stream processing. Now, if you think of only the core Kafka as a system, this is how stream processing happens. One, Kafka as a system is an aggregation of, it's a pub sub system. So there are events that can be published from your data sources, be it databases or applications, and then whoever wants it can subscribe to relevant topics and then get the information out. But essentially, the core system is going to do a pub sub activity. It's going to store the information, but by default, it's not going to change or process the data which is stored in the system. For that, what people were doing is they use whatever connectors or code to get the data into Kafka, which you see as step 2, and then use some kind of third-party processing tools, be it Spark or Flink or Storm, to actually go and do the stream processing and then put the data back. And more often than not, these kind of processing becomes batch-oriented rather than real-time. And then you get the data out to relevant sync systems, be it databases, Redis cache, or your applications, so that your applications can go and act on top of the enriched data on top. Right. This is a little tedious process, and it doesn't happen always all in real time. So what we did as Confluent is we have compressed all the processing pieces, connecting pieces where you can get the data in and out, and generating or enriching the transformations. All of it, we have packaged it in a simple product called ksqlDB. So ksqlDB will help you to get the data in, do your transformations, generate all the views that is required, which is almost ready for the applications to directly consume it. Of course, it's going to connect with Apache Kafka as a backend system to interact with and then do further processing. So this is how it actually simplifies, rather than taking a long approach, which is batch oriented. We are going to leverage ksqlDB for getting the data in, doing transformations all in real time, and then get the data out to whoever actually needs it. Right? This is the essence of why ksqlDB becomes important. And in fact, in Confluent itself, we have 3 different solutions for doing stream processing. There are people who still go and do stream processing by writing a bunch of lines of code in their producers and consumers. That is still possible, but it's not so simple. Then we have introduced Kafka Streams. Kafka Streams is nothing but a Java library. It simply have all those transformations as functions. So you can simply call the function to get the job done. But still, Kafka Streams requires somebody to have programming knowledge, and specifically Java. So only if they know programming, and only developers can actually go and leverage Kafka Streams to do stream processing. So what we did as a result, and to make it much more simple and easy for everybody to use, be it data engineers, be it non-technical folks who don't know programming, right? So we built a wrapper around Kafka Streams, which is nothing but ksqlDB. To draw parallels, it's just like your normal database systems, right? Database systems are going to keep data, and then you run SQL queries to get the data out. But here you want to do very similar thing, but with real-time data where thousands of records are coming in. So we have leveraged ksqlDB to work on SQL style syntaxes itself. An example that I want to show is this. Say, for example, you want to just count the number of streams that are coming in, which is very, very simple, very simple use case, right? This is how you achieve in three different products. With producers and consumers, you write a bunch of lines of code. With Kafka Streams, you call some libraries, but with ksql, you are just going to write a simple SQL style syntax to get the work done. So it becomes so simple for people to use and consume ksqlDB. And it has also built for resilience, which means it's ready for production. It is a distributed system, just like Kafka. It is also inherently a distributed system. It can handle failures. When a node goes down, it's going to automatically trigger rebalances and then distribute the load. And when node comes back, it's going to again trigger rebalance and do it. All of this is transparent to you as a user, so you don't need to really worry about nodes failing and the migrating the tasks all from different places, right? Now, how can you use ksqlDB? We are actually going to use GUI. GUI is already built in Confluent Cloud to use ksqlDB. And today, as part of Handson workshop as well, we are going to leverage GUI to do the stuff. For people who are interested in CLIs or APIs, we have options for CLI-based and API-based access as well. So you can leverage ksqlDB with all the three options that we have talked. Now let's go a little deep and understand some constructs of ksqlDB. So these constructs will help us to do our hands-on exercise as well. Right? The first things that I want to talk about is ksqlDB has fundamentally two types of collections. One is streams and second one is tables. Streams is nothing but just like your topics. It is immutable and append only sequence of events. This helps us to completely trace back everything from the beginning of time. So if you see an example here, GIF here, there is a vehicle ID whose latitude and longitude is being tracked. And when another latitude or longitude is coming in, it's not going to replace an existing value. It's just going to append new values as part of the stream. So it becomes immutable. On the other hand, table, unlike streams, is going to be a mutable set of collections. This is very, very similar to your databases, where for a particular key, in this case, which is vehicle ID, only the latest value is going to be retained. All the older values are going to be rewritten or updated with the latest value that is available. So streams and tables are fundamental to constructs in which you can actually get or model the data in ksqlDB. And there are use cases which we are going to discuss later. Now, once the data is in as either as a stream or as a table, now you want to run some queries and get the data, right? So we have this concept called push queries or persistent queries. It's very important to understand this in little more detail, because this is where the real-time piece actually comes in, right? Say, for example, there is a ride application, right? So the distance of every ride that is happening, and marketing wants to offer discounts based on the ride. Say the ride distance is more than certain kilometers, it want to automatically apply a promotion and give certain discounts, right? Now you cannot wait for all this process to happen sometime later, right? So all this process, while the person is taking a ride, you want to track all the coordinates, you also want to compute the distance, and then you also want to apply the logic and see what kind of promotions can be applied. So even before the ride is complete and person is getting out of the ride, his promotions are already applied, the marketing campaign is already applied. That's a use case that we want to do. It really becomes hard if you use normal databases to do this, because you have to run a query continuously to compute the distance. So if you want to do that with database, that becomes very, very hard. And databases are fundamentally designed for accepting the data and keeping it at rest, and then run a query sometime and get a result. That's it. It's not really designed to run a query on a continuous sub-millisecond or sub-second basis to actually get a result. Here, what we are doing is we are going to run a persistent query, which is going to continuously run in the system. It's going to continuously compute that particular distance on a sub-second basis. And then when the distance exceeds a particular distance, it's going to automatically apply the discount. So this query actually runs on a continuous basis or unbounded stream, and you can also get a materialized view out of it. So we are going to run some query and see the query will show running. So it is always persistently going to run as long as you are going to manually go and stop it. This becomes very, very important because all we are talking about is real-time applications. In real-time applications, there are thousands and millions of data points that are coming in on a per second basis, and it is very important to do the computations with so much of data on a per second basis. That is when you actually get a real-time results as well out. Right. ksqlDB, on the other hand, also supports pull queries. This is very, very similar to normal database queries. Right? You just want a static data, like I want to know the location of a particular car. I want to know the location of a particular driver. You can run a query, get a result, and the query ends there. It is not persistent. You just want a particular static information, the current state information. Run a query, get a result. That is also possible with ksqlDB. So far what we have seen is there are streams and tables that you can construct. There are queries that you can use to get the type of data that you really want for building your real-time application. To put it all together, so you can capture events, you can do your transformations, you can create your materialized views, and then you can serve those materialized views to, say, applications or whoever actually needs it. So all of this is actually happening in real time, all with ksqlDB. Some examples of what kind of transformations we are going into transformations and see what kind of transformations can be there. I'll first start with some very basic low level transformations, and then we can see some complex transformations. One is filters, right? So obviously you have a lot of data coming in, and say in this example you are collecting an IoT data, and you want to only filter the data which is more than 41 degrees Celsius. It's a temperature data. You just want to filter and store it in another place so that somebody can consume it. Say that will be used for switching on cooling systems. So you can do that by just writing a code, very, very similar to the SQL syntax. You apply a condition and then get the data out. Similarly, you can join. So you might have multiple streams of data actually stored in different topics. You want to actually join the data from two different topics and create another enriched topic. In this example, we want to actually see sensors data and its brand name, what kind of brands are different people using, and so that we can do some more extra R&D effort on top of those particular brands. So that is where one use case where you can actually join data from different things. Remember, it's not just that you can join data just from streams. You can take data from stream and table as well, like you see here, and then join it. That is possible as well. A third thing is aggregates. You want to compute something like your sums, your averages, and stuff like that, percentages. You can do that as well. Here we are trying to get on a per location basis and a per sensor basis, what is the average temperature, right? So you can compute such kind of aggregates, and ksqlDB can handle this kind of stateful operations as well when it comes to transformations. And very importantly, because we are talking about a real-time data, so time becomes a very important axis, and you might want to do some transformations based on time as one of the fields or one of the axes, right? So you can think of use cases like, say, you want to run some marketing campaigns and you want to see how many ads are clicked in that past hour, or you want to do some telemetry data analysis and you want to actually get the data on a minute interval or 5 minutes interval and compute some averages, or you want to actually analyze a particular session. A user logged in, say, in a shopping website, and he has done some clicks, he has browsing sessions. Such are some examples of windowing, and in ksqlDB you can do three types of windowing. One is tumbling window. The graphic itself explains, so you can have fixed length of windows which will change on a per size basis. You can have a hopping window, which is going to advance on a continuous basis by the advanced parameter that you specify. So you can do such kind of thing, or you can do a session-based aggregates as well. So where you are going to specify the session timeout as a parameter. So it will take care of all the events of that particular session and group it. So you can do further additional transformation on top. So these are some kind of fundamental transformations on that you can start doing. Now let's take these fundamental transformations, what we have learned so far, and then apply it to real use cases and see what kind of things that you can actually do. All right. One basically is you can obviously use ksqlDB for doing data exploration. So simply you want to get the data and see it, right? You want to filter the data. The last piece is where you are applying some logic and then you're just getting data, and you don't want all the fields. You just are selecting some fields and getting it. This is very simple and straightforward. You're just using it for data exploration purpose. Just want to see the data, what is there. The second use case is you want to start doing some kind of transformations. Say people who know Kafka, you might know there are partitions in it, and sometimes you want to increase the number of partitions. Or you might have initially designed the data with only values, you didn't leverage keys at all, but today now you want to leverage keys and you want to completely construct the whole topic so that you give some parameter as a key and then completely construct the whole topic. So you want to do relevant additional transformations on top. Such kind of things are some transformations that you can do as next level with repartitioning and transformations. Now let's talk of some more very close real-time use cases. Say in case of an IoT, right? You are a car company like Tesla's. You can imagine there is a lot of information that are coming from your vehicles in real time, and you want to do proactive maintenance or proactive alerts to your users if something is going wrong. So in this case, what we are doing is there is a vehicle monitoring stream that is actually coming in. We are collecting all those data in a stream, and then we are using windowing technique so to filter it on a per minute basis, and then seeing how many error messages are coming in, and if the error count is more than 5, which means in a per minute interval, if there are 5 error messages coming in, it means something is going to be wrong. And this logic can be defined by you based on your scenarios, and then you are dumping the whole result into another table called failing vehicles, where now your notification system is going to simply listen to the failing vehicles, and if it sees new entries, it's going to alert both your backend system as well as the consumers that something is wrong and you might need some maintenance or go and visit a showroom types. So that is one kind of real-time monitoring use case. The second use case I want to talk about is say clickstream analysis. You are collecting a lot of clickstream data and you want to target the data for a particular ads or a particular campaign. So you can simply take the stream and then join it with users, which is a table. You're doing a left join here on a particular key and ID, and then you are filtering only the VIP users. Probably you want to do a marketing campaign for them. You are filtering it and then taking relevant fields that you really require and then putting it in another stream. Remember, clickstream is going to have thousands of data points on a per second basis. So the result is also a stream, which is going to collect a lot of data on a per second basis and dump it in a stream, which can now be queried by your application to do some kind of marketing activity on top. So in this example, we did some filtering stuff, we did some cleansing stuff, we just chose the required fields, and then we are doing the process all in real time. Right. Another example is a retail industry probably. So you want to compute the inventory in real time. You get the sales data from one side, you get the shipments data from another side. You use ksqlDB to run your queries and then store the inventory in hand, say in MySQL or any other application. So instead of actually waiting for some batch process where the inventory gets updated on say a 30-minute interval or a 1 hour interval, you actually get to see the inventory almost in real time as possible. Another possible use case is anomaly detection. This would be relevant to banking, finance, and BFSI sectors. Say you want to actually go and check the number of authorization attempts that are happening on a per user basis, applying the window logic, and then seeing. So, humanly speaking, it's not possible for a particular person manually to log into a system 3 times in a small interval of 30 seconds, which means there is some kind of fraud happening or there is some kind of uh, uh, anomaly that is getting detected. So the result of all these things is going into a table, and then this table can be queried so that you can actually inform, say, a customer, or you can actually use it by your security team for further processing. Right? So these are some of the use cases that you can think of for doing real-time stuff. Now, we we just finished 36 minutes of our session. So let's go back to our hands-on piece. Please keep the questions coming. Let me open the chat as well, so I can actually see if you have any questions. And while we do the hands-on piece, I'll work on the questions and then answer you guys as well. So now if you go back to your consoles, the Confluent Cloud console, you should see that ksqlDB status is up. For people who probably joined late, there are links that I've already posted in the chat box, which you can refer to. We are doing a live hands-on real-time data exercise, data streaming exercise. So I've posted a procedure. You can create your Confluent Cloud account. New signups get $400 free credit. Today we probably require maybe a few dollars, not even $10 to do our exercise. But that will be a good place to start. You get a real hands-on feel of how a real-time data processing is happening, right? So far we just created an account. We created a Kafka cluster, and we have created a ksqlDB cluster. Right. So let's move ahead and kind of start the hands-on piece. Now I would request you guys, if this ksqlDB is up and running, that's a good news. So just go to the data integration tab on the left side, click on API keys. Remember, because this what we offer in Confluent Cloud is a fully managed Kafka along with all the other components like ksqlDB. All the data is encrypted, so every access is API driven. So you need an API key and secret to perform all the operations. Now, like I showed you in the architecture, ksql itself is a separate part, and your Kafka is a separate part. So all these are also going to interact using API key pair. So that's for your security and compliance reasons. Just generate one API key at this page. You can give global access. That's okay for the demo sake and for development purposes. You can just go and click here. Copy both the API key and secret so that you will actually be using it a little later. And click download and continue. So this 3 clicks is going to generate a particular API key for you. If you are getting this particular page, you can simply skip it, not a problem. And you will get an API key, and it should as well, it should have been downloaded just for you to make use of it a little later. So let's wait for 20 seconds. If you have generated API keys, we can go ahead. You can just type 4 in the chat box so that I'll come to know that the 4th step is complete. So there's a question. Let's take that. You mentioned that the key attributes in Kafka topics are immutable and not updated, but appended every time there is change. So in this way, database will keep on increasing and it will need infinite database space. So how do we manage huge DB dynamic sizing? Awesome, good question. So fundamentally, Kafka is a system, right? People use it for a lot of real-time use cases. If we are talking about open source Kafka itself, that's the default retention period is only 7 days there. You cannot actually retain data more than 7 days in an open source Kafka kind of systems. But what we have done as part of Confluent is we have introduced something called infinite storage as well as infinite retention. So fundamentally, Kafka is a PubSub system, but storage is decoupled. What do I mean by that is the data sources are publishing data, and data consumers, subscribers are subscribing and consuming data. Unlike MQ systems, the data doesn't get deleted as soon as it's subscribed. The storage part is decoupled. It doesn't matter how many people are actually consuming the data is still retained, and the retention period is something you define it either as a storage parameter. Say my capacity is 1 TB and I want to store 1 TB. It doesn't matter how many days of data it is. Or you say the period, which is 7 days, 1 week, 1 month, or whatever time it is. In Confluent Cloud specifically, with all the 3 major cloud providers, AWS, Azure, and Google's, you can choose to retain the data forever. It could be years, 10 years, or whatever, years as well. So we have infinite storage capability as well as infinite retention capability. Second part of the question is about dynamic sizing issues. Because we give it as a fully managed service. There are a lot of people who give Kafka, but those are not a fully managed service. We are giving Kafka as a fully managed. Fully managed means it starts not just with provisioning, day 2 operations, scaling, upgrades, patches, your high availability, your nodes going down, EC2 instances or VMs or containers going down, all of these is handled by our backend team. So that's what it makes us unique, and it becomes a fully managed, a really fully managed service for you. So all the scaling issues, how to scale storage, how to scale compute, all of this is already designed as part of the systems, and we are leveraging hyperscalers for doing this functionality. I hope it answers the question. Anshu. So let's move ahead. So I want next step is let's go and click on the learn button that you see on the top right corner. There is a learn button. A quick thing, if you want to do this exercise or learn more about Kafka and Confluent later as well, this is a page which will be very, very useful for you. This covers a lot of tutorials. This is for very, very people who start with very basics. What is Confluent Cloud? What is ksqlDB? And other pieces of Confluent Cloud. The developers can leverage how to build client applications, both producers and consumers. We have a lot of tutorials with sample codes there. And we are going to leverage some kind of recipes now. And there is a lot of video content as well as hands-on content as well that is available in the same page. So you can anytime go back to this page and leverage all the content that is published here. Right now, for the sake of this exercise, just go to the top and click on ksqlDB recipes, or as well you can land up to this section called recipes, and then click on very first type where it says understand user behavior with clickstream data. So for the next 7-8 minutes, what we are going to do is we are going to do clickstream analysis using some dummy data that gets generated. Once you click on get started or continue tutorial, whichever is applicable for you, you should actually see a page like this wizard popping up on the right side, and it should already give a tick mark against create a Kafka cluster and create ksqlDB cluster. Remember, we have already done this at the beginning of the session itself. So they should already show a tick box. For some reason, if it doesn't show, just leave the tutorial, come back to the same page, click on the same thing. Sometimes because of cache, the problem comes in some browsers. It should automatically show a tick box again, first 2 items, and the third item there should be a pink ball just glowing there. So click on continue with tutorial, which will actually take you to an editor page where a lot of queries are there, and it is actually auto-populated. Remember, we have captured API key and secret. Let's go and actually go and use that here. Let me paste the secrets first. You can you'll have to do it in 2 places, like I'm showing you on the screen. There are 2 connectors that we are essentially spinning up. So there is an API key secret that you have to give in both the places. So you can just input both the API key and secret in the relevant places. Once that particular step is done of copy pasting API key and secret in both the connectors, go to the bottommost of the same page, scroll down, and there is a section for sync connector, which is after the row number 130. You can simply delete all the rows after 130. So you can simply select all the rows and then completely delete it. We'll talk about sync systems a little later. Right. Once you have replaced your API keys and deleted the sync part, just simply click on run query. Run query is going to show a pop-up saying it's going to spin up some more resources, the connectors and some resources, and it's going to charge you. No worries, like I said, there is $400 credit and it will take care of these connectors. So click on continue, and that's it. So you can just leave the process to happen. It's going to take about a minute or so for all the queries to run, generate resources, generate some dummy data, and let's see what is happening. While that is happening, let's revisit and see what we are actually doing today, right? One, like I said, there are connectors. Essentially, in real world, you are going to use some databases or some applications to get the data in. Here, we are using a programmed data gen connector to get the data in. So fundamentally, we are generating some users data, and then we are generating some clickstream data into the system. Right? Now, we are going to, we saw the concepts of stream and table. So clickstream is essentially a stream. So you don't want to lose any data or overwrite any data. So create a stream. We are creating a stream out of clickstream data by giving all the relevant fields that we require. And similarly, on the users, it doesn't make sense to create a stream because today as a user I can sign up, but tomorrow I can go and change my city or change my name or change some parameters to it. We just only want the latest information, and we are not worried about some historical information. So what we are doing is like table is a mutable set of events, like I said. So we are creating a table out of the user's data that is going in. Now, one thing to note is by the nature of connector itself, what happened is, if you notice the user ID, right? User ID from users is a varchar, which is a string, but the user ID from your stream or the clickstream data is actually an int. So that's one thing we have to handle it as part of queries as well. Now let's go ahead and see what kind of use cases we are generating, right? So first things first, we are going to enrich the data itself, which means we are taking the clickstream data, because the clickstream data is not giving me the user's information of which city he belongs to and stuff like that. We are going to join the data. In this, simply we are taking clickstream, doing a left join with user's data. Like I said, there is a difference in the type. So we are casting the type here and then applying a join logic. So it is creating another stream, which is user's clickstream here. The second thing what we are doing is we are seeing how many HTML pages are browsed by a per user on a per minute basis. This will help us understand what is the interactions of the user that they are doing, and probably design some campaigns or some more stuff on top, right? So here we are taking a clickstream data, we are applying a window logic of 60 seconds, advancing it by 5 seconds, and then taking all the web pages. So there is a HTML there, grouping it by user ID, counting the number of pages, and then storing it in another table, pages per minute. So that table, when we query, we'll actually get to know on a per user basis how many pages they are visiting on a per minute basis is what we'll get to know there. The next thing what we're doing is user sessions. We are trying to take the users data and then trying to see how many clicks they are using on a per session basis. The session timeout is 30 seconds, or you can even put the actual session timeout there. And then we are counting the number of events that the user is doing and storing it in a table called click user sessions. The next thing we are doing is we also want to see the experience what the users are actually facing. Probably maybe some pages may not be working, or they're getting some errors. In fact, we face that. We sometimes when we go to Amazon, it gives a little puppy and says the page is not available. So we want to actually track, or the backend operations team want to actually track such kind of things. So in this case, what we're doing is we are taking the clickstream data, applying some window logic, and then taking all the error codes where the status is more than 400, where essentially it's some kind of error. And when the count is more than 5, which means in a per minute basis, if there are more than 400 error codes, we are storing it in particular table called errors per minute alert. So using that, we can go and see if something is wrong with the backend as well. Similarly, last thing that we are trying to do here is we are trying to aggregate stuff. We are taking the clickstream data, and then we are seeing a typical example, right? So people create one Netflix account and use it across the globe. Actually, people use the same login to login. So to kind of detect such things, we want to see on a per user ID basis, if there are more than 2 logins happening at in an interval of 60 seconds, and we are tracking their IP address and city to see if both the logins are from same city, or actually the user either is compromised or he's actually sharing credentials to somebody else outside. So 2 people are logging in using the same credentials from different cities and different IP addresses. These are some of the use cases that we have actually built, so it's already available. Now, by this time, your query should have run. You see a lot of things popping up on your right side, ST and TB, which are streams and tables. All the concepts that we have discussed, like streams, tables, all are available here. You see streams, tables, and all. Now the whole flow, what we talked about, right, is pictorially represented in this particular tab called flow. So just ignore the log. This is the ksqlDB's own log. So we took the clickstream data, we took the users data. Now you can, on the right side, you can actually see, for example, clickstream data. So I said we are doing real time. So you will actually see thousands of records coming in real time. So you see the timestamp and all the data changing in real time. Right? And then we run the queries. These are the queries that you see as in these boxes that we actually run. So as a result, it is creating pages per minute, errors per minute, users clickstream, and all the relevant outputs that we just discussed so far. Right? So it's a pictorial view of how you can go and transform the data without taking it out of Kafka. We are leveraging ksql to do all this kind of filters, joins, windowing operations, time-based operations, storing it so that it is immediately and easily consumable by whoever actually needs it, be it marketing team, be it analytics team, or whoever it is, right? And another thing that I want to touch upon is stream lineage. We just saw a pictorial representation of what is happening just with the ksqlDB alone, right? When you actually go to stream lineage, this will take some time, but it is going to generate a dynamic view of the whole stuff that is happening inside Confluent's perspective. Let me open a setup which is already running. So you get to actually see pictorially. You don't need to do anything for this. It's going to dynamically generate after some time once the data is coming in. So this is a complete view of starting from connectors, who is generating data, which topic it is going to, what kind of queries you are running, as a result of query, where the data is getting stored, and all the metrics like how much data is getting transferred, everything you can actually track. And it's a beautiful representation of your complete data pipeline, which you can give it to your higher end leadership team, so that they'll actually have a whole view of what you're actually building with Confluent as a platform. So I'll take a pause here. Any questions? So if you are able to run the query properly without any errors, like I said, you have to replace your API key secrets and remove the sync piece. So you will actually be able to see real-time data coming in, all the operations happening in real time, and a transform data coming out. Now, purposefully, I didn't discuss much on the sync systems, but you can export this data to a lot of sync systems. We have more than 200 plus readily built connectors which are available in Confluent Cloud. Say you can take it to Elastic, you can take it to Snowflake, you can dump it in MongoDB or say S3 or some kind of storage, so that people can actually act on top of it after consuming it from there. Or as well, you can write a code where you can directly pull it from ksql itself without actually going and putting it in some kind of system. So that's it on the hands-on piece for today, but there are a lot of learning sessions in this Learn tab. Like I said, there are many use cases that we have already readily built. You can as well replace the data with a real data like a Postgres tables or some kind of applications. You can write your codes, basic information of how to do it, including videos and some sample codes are all available here. I hope you enjoy the session. Please let me know if there are any questions. I'll go to chat now. Otherwise, let's see if you are stuck anywhere and if you need any help. Any questions so far, team? I guess we are on top of the time. We just have some more. Okay, we are actually top of the. So yes, yeah, good thing. Yes, good you reminded me. Thanks, Anshul. So all these are real resources which are actually running. So I would request you to delete it if you are done with the exercise. The order in which you do is first go and delete the ksqlDB cluster. There is a delete button there. You can the query automatically is taken care if you delete the ksqlDB cluster. The next step is go to connectors because as part of code itself, we have created 2 connectors. So you can go to connector page, 2 connectors will appear. You can delete them. And the third thing is you delete the cluster itself. And all of this should consume less than not even $1, I would say. But yeah, it's good practice to actually delete it. Anyway, you have $400 credits. And that credits are available for 60 days. So feel free to come back, learn a lot of content. There are a lot of learning resources. You can as well contact me or the other marketing team and sales team. I have posted my LinkedIn link as well. You can connect with me and we can discuss. So ultimately, let's go and do a lot of real-time stuff. Batch is old, so let's get all stuff in real time. So let's discuss how we can help you with business all in real time. And we have a lot of sessions lined up as well. Janice, if you want to post the links of subsequent workshops and sessions that are happening, you can do that. I'll stop screen share, and if you have any questions, feel free to reach out. And we also have sessions from our own team, which is now a roundtable is going to happen, and later in the day there is going to be a talk session by one of my colleagues. So feel free to go and attend those as well. Thank you so much. Thanks for your time. I hope it was helpful in learning some bits and pieces. leverage all the resources that I've showed you, and please feel free to connect with me, contact me, or other people of Confluent team to help you with whatever business cases that you have.